question is valid anagrams. So this is a LeetCode question, valid anagrams. First, let's see what's an anagram is. What is an anagram string? A word or text formed by rearranging the exact same letters of another string. So that's the definition of an anagram. So we are given two strings. Okay. We have to return true if T is an anagram of else false. So we have two strings. Like, let me write it here. We have a string anagram and we have a string nagaram. And we have to tell whether these are anagrams or not. So let's discuss approach number one, that is sorting and comparison. So let's see this first. If we sort this string, what will it result to? A sorted S is equal to A and again A, then G, M, and then R. Seems right? Okay, seems right. So we have sorted S and we'll also sort T as well. It will again give us the same string and then we'll just compare them. If sorted S same as sorted T, then it's a valid anagram, else it's not a valid anagram. Okay, let's discuss another approach. For this we need to understand a concept that is ASCII values. So because I am doing this in JavaScript, here A has a ASCII value of 97 and Z has, I guess, 117. It's 122. So all the numbers like B will have 98, C will have 99, and the sequence goes on. I have already written here in the table. And another condition of anagram is frequency of character of a particular character in S should be equal to frequency of that character in T. Then only it's possible to form an anagram. That seems obvious because if you see both sorted strings, A appears exactly 3 times, G once, M once, N1s and R1s. So in this approach, we'll have a hash map. Hash map like this. And okay, no, I'm doing something wrong. So in this hash map, we will store character and frequency. So we just understood that one condition to form anagrams is in both the strings, frequencies should match for a particular character. And we have also found that each character has a value, ASCII value of 97. Just a numerical representation of a alphabetical character. So A is 97, B is 98, C is 99, and so on. Z is 122. So if I iterate over the string and just store for, or the better way is this one: A, 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 not this one, but anagram. A, G, R, A, M. We have to iterate over this array of strings, array of characters. So first we are at A. What is the frequency of A? There are no A at in our map, so we'll say we have one A here and one. Again A. So we will not create a new entry but just update existing frequency. We'll say the frequency is 2 now. G. G is also once. R. R is also once. A. So we similarly will not create a new entry but just update from 2 to 3. And next M. Okay, and you can do the same process for Nagaram with another map, and then you will compare the frequency. and so you'll have a similar character to frequency map for both the strings. So this was for anagram, this was for nagaram. Okay, let's take it one level up and make it even simpler. So as we have already discussed that each character is represented by an ASCII value. So can I say if I have a in anagram, I must have an A in anagram as well. If I have N in anagram, I must have an N in anagram as well. So instead of creating two maps, what we will do, we'll increment the frequency of A for anagram and will decrement the frequency if we found that A also is present in anagram to maintain a balance. Let me tell you how. So here A N A G R A M. Then we have N A G A R A M. So I'm at A and N. I'm looping over the string. So my pointer is at A and N. I'll say count of A, count of A is 1, count of N is also 1. Let's move forward. Then I found N. For the first string, I'll keep on incrementing the frequency, and for second string, I'll reduce it to maintain a balance. So we are at N and A. Let's increase N. Oh, sorry. Here we did a small mistake. We have to increase frequency of A and we have to decrease frequency of N. So we had no N's, so it should become -1. Now at N comma A. Here we will increase the frequency of N. So N should become -1 to 1. In A, we'll decrease A. A should become 1 to 0. Let's move forward. Again we have A. We have to increase A. From 0 to again it becomes 1. And G, we have to decrease frequency of G. G from 0, it has no occurrence in our map, so it's 0 and we are decreasing, so it becomes -1. Now we are at G and A. For G we have to increase, so -1 becomes 0, and A we have to decrease, so -1 should become 0 now. Now we are at R. We have to increment R once and we have to decrement R once. So R still stays as 0, +1 and -1. R is 0. Sorry, it seems like I did a small mistake. From -1, n becomes 0, not 1. And we are at A. So we have to increase A once and we have to decrease A once. So if you add 1 and remove 1 from 0, it still stays 0. No change. And we are at M. Still the same. There is no frequency, so you start with 0 and you add 1 in 0 and you remove 1 from 0, so it stays 0. And last, you have to compare every character's frequency should be 0. If it's 0 means we had a balance of addition and subtraction. And for A it's 0, for N it's 0, for G it's 0, for R it's 0, for M also it's 0. So we can say anagram is these two strings S and T are anagram. So let's write here. So here it's a valid anagram. Can we iterate the similar solution for a failing case? Let's try. Do we have a failing case here? Yes, rat and car. If we apply same approach, let me create a line here for a separation. And we have R, A and T. We have C, A and R. Okay. So we are here at C. Our pointer is at R and C. And R is 1 because incrementing, and C is -1. A. A is, if you add 1 and remove 1 from 0, it stays 0. No effect. And T. You add 1 and for R you remove 1. So it's 1 and if you remove 1 it becomes 0. So finally if you say R is 0, okay. But C is -1. T is 1. So we have two non-zero characters. So that makes rat and car not an anagram. So you might have understood our logic, and let's see the solution, a code walkthrough of this. So this is Java solution, but I am preferring JavaScript because I know JavaScript. So first we are converting t into array character, and we are filling it with 20, we are filling it with 0, means an array of size of 26 all filled with zeros. So representation of that is this comment, and we are assuming it's an anagram. I guess we could have done better instead of using this uh, variable, but I'll show you that in a minute. So for all the s characters, we are converting it into an array, and for each character we are looping over it. So we have created an alphabet array. So the approach I said you of map, right? So at a we are incrementing, decrementing. At n we are incrementing, decrementing. So this is same resemblance is this array, because see the array is of fixed size of 26, right? So it should be something like this. Should be something like this, and you'll have indexes here like 0, 1, 2, 3, 4, 5, 6, 7, until last it will go to 25. And at 0 we denote it with a, and we'll store here frequency. So like here in the case of rat and car, a will be 0, then r will have some number, so that r will store 0, then c will store some -1, and then a already has 0, and t will store some 1. So this was just a map representation, and we are not using map because an alphabet array of fixed size fulfilling our condition. So looping over s array, and in the our alphabets array we are converting the present character into zero to 25 range. How we will do that? So we have already learned that a is 97 and z is 122. So you have to convert this into 0 to 25 index. You'll subtract any characters ASCII minus a. So suppose you want to get index of b, what you will do? You will do b minus a, like 98 minus 97 is equal to 1. So b has an index of 1, a has an index of 0, c has index of 3, and so on the list goes on. So we use this method. So this gives us some number, and a dot character code dot 0, this will give us 97. And as I have said, in the case of first array or first strings array, we are incrementing the frequency. So at that index of the array that denotes the alphabet itself, we are incrementing, and parallelly we are decrementing as well. Like I have said here. So here we used char, that is coming from the S, and same index in the T strings array, characters array. So we are not doing it with two loops. Single loop is satisfying our condition. We are using the index to move forward. So it increments and this line decrements. With this, our whole iteration to form a map kind of thing works. And next, as I have said, we have to count all these frequencies to be 0. So in the alphabets array, if the character is not 0, then it's not anagram, else it's an anagram. So we have assumed that it's an anagram, and if it passes all the conditions, then it's an anagram. Else if it fails, if it's a non-zero in the alphabets array, then it's not an anagram. So let's discuss the approaches. As I have said, sorting. We could have done it with sorting. So sorting is n log n, and space is constant because we will not use any kind of space in that. In the hash map approach, what I have told here, of n, because we are maintaining a hash map of size n. N is the string length, and space is constant, or O of k. And space is constant still because it's a fixed size of 26 alphabets, 0 to 25 index. So a fixed size always counts as a constant size. And another approach we have tried, that is array, fixed array. That's also O of n complexity because we are iterating over each element, each character once, and space complexity is constant because it's a fixed 26 characters length array length of 26. And that's all. This was an interesting question, though it was a simple, but it will require you to know about the concepts of ASCII values. And let's run this code. As I have said, I can improve this. Will not use this, and instead of for each, we can do for const char comma index of this array, sorry, here it's not necessary. The reason we have used this is anagram variable because from inside for each you can't return. You can just return outside this callback. So if you want to return outside of this function directly instead of using this, so we'll do something like this. A bit cleaner solution. Um, I guess we did something wrong here. Let me see. What wrong we are doing? I'm not getting what wrong I'm doing. We are converting a string into an array by spread operator, and then array dot for each. What it's saying, let's read. Unsafe token. Oh man. These kind of silly issues. So we must put a semicolon before this. Looks like working now. I guess we have to take care of the case if both strings are not of same length, then it can't be anagram.